Another important thing to think about when we talk about electricity is that different kinds of materials handle the motion of charge through them very differently. You've probably already remember hearing about this, but materials can be broadly classified into two different types: insulators and conductors. And the difference is how easily do charges pass through these things. Electrons, as we talked about, are much more mobile than protons, and so when charges move, it's usually the electrons that move. Electrons pass pretty easily through conductors. Conductors are things like metals. Gold is a really good conductor. Silver is also excellent, and copper too. Aluminum is another one. Most of the wires around you are probably either made of copper or aluminum because they're a lot cheaper than silver and gold. Insulators, things like rubber, plastic, and glass, those are things that electrons have a really hard time getting through. And so we call them insulators because they insulate the flow of electricity. There's a difference as to how these things will react when we put an electrical charge on them. If we rub a balloon on someone's hair and it picks up a negative charge, that balloon is made out of insulating material, and so those charges can't really move very easily, and they stay stuck to one part of the balloon. No matter how long we wait, those charges aren't really going to cover the rest of the balloon. A conductor is different. If I add an electrical charge to a conductor, say a piece of metal, like this here, very quickly those charges are going to spread out and cover the entire surface of the metal. They do that because they don't like being squished together. They're all negative after all, and so they'll repel each other and spread out as much as possible. So the fact that insulators don't let charge pass through them makes them very useful. We cover wires with rubber or plastic so that we can insulate the flow of electrons through the wire. In this diagram here, this sandwich is meant to represent a cross-section of a wire. And the top and the bottom layers are insulating plastic. And inside, that green slashed part is meant to be metal of some kind, a conductor. Those red electrons are passing through the wire. They're moving from left to right. They can pass through the metal easily, and so the metal is a really good way to transmit the electrical energy. On the other hand, we don't want the electrical energy to come out the sides of the wire. If you grab this wire, we don't want you to get electrocuted. And so we put insulation around the wire so that the electrons cannot travel outside of the wire. And this is what makes wires able to carry electrical signals without zapping people who touch them. Your nerves work in a similar way. In your body, electrical impulses are sent through your nerves, but there's a coating of cells on the outside of your nerves that insulate and keep the charge from leaking. And this is very important to the functioning of your nervous system. There are different ways that objects can gain an electric charge. One is called charging by contact, and as the name suggests, that means that somebody has to touch something. This is how the balloon worked. By rubbing the balloon, we actually were touching the two objects and a charge was transferred. There's another example using what's called a Van de Graaff generator, and it's very amusing. This kid has got his hand on something called the Van de Graaff generator. We're going to see what that looks like a little bit more in just a second. But as charge is fed to this Van de Graaff generator, and as he touches this charged thing, that charge flows into him and eventually causes his hair to stand up. And when the charge is removed, his hair falls back down. So he's being charged by contact. I hope that we can demonstrate this in class someday. It's a lot of fun. So charging by contact. So this kid is touching this Van de Graaff generator, which produces a whole bunch of positive charge on its surface. As he touches that surface, you can see his hand picks up the positive charge as well. And because people are pretty good conductors, that charge flows and fills his whole body, including his hair. Now, because each of his hairs is positively charged, they want to repel each other, because likes repel. And so his hair stands up to get as far away from all the other hair as it can. If it was laying down flat on his head, it would be pushed too close to the other hair, and so it stands up to try to repel away from all the other hair. Pretty funny, huh? Another way to charge something is called charging by induction. In induction, there is no touching. Two things will get close to each other, but they won't actually ever touch. So imagine if that kid from the video with the crazy hair, here he is on the left, imagine if he starts walking towards you, carrying his positive charge. Well, you're neutral. In my little diagram here, you have 6 positive and 6 negative charges. But as he gets near you, he's not going to touch you, but as he gets near you, his positive charge pulls all the negative charges in your body towards it. All your mobile electrons will move toward him. They're attracted to his opposite positive charge. And so your left side becomes negatively charged and your right side becomes positively charged. You're still neutral overall, but your left side has a negative excess, 6 negatives and 3 positives, so a negative excess of 3, and your right side now has a positive excess of 3. Conservation of charge, but the charges have separated a bit. If you happen to touch something like a metal doorknob, because your right side is positively charged, any free electrons in that metal doorknob are going to race in and join the empty positive charges on your right side to cancel them out. And now if you look, because all your positives on the right side now have negatives with them, if you count up, your whole body now has an excess of -3 charge. Okay, so there's still some touching involved in order to charge something through induction, but you're not actually touching the guy who was charged to begin with. So that's the main difference between charging by conduction, something has to touch the thing that's charging it, and charging by induction, you just have to get near the thing that's charging you. The book gives an example as well using something called an electroscope, and you'll read about that. I just thought it might be useful to have a different example, like that crazy kid with the hair. Okay, for homework in this section, I'd like you guys to read the whole section, 7.1. When you get to page 201, please take a crack at questions 1 through 6 and send those to me by the end of the week. Have a great day, guys, and I'll see you in the next section.